So what I'm working on today is a modification for my sandblasting cabinet. If you search YouTube, you'll see a ton of videos on how to modify the Harbor Freight sandblasting cabinet for some better performance and feed, etc. This is kind of along those same lines, but I don't have a Harbor Freight sandblasting cabinet. I have a clone of a Skatblast cabinet. Very nice cabinet, very nice machine, but it traditionally used a siphon tube down into the media with an air tube, very similar to many of the cabinets, including the Harbor Freight cabinet. But what I'm doing is I'm getting rid of the siphon tube, and I'm going to have a feed at the bottom of the cabinet, a lot like some of the Harbor Freight mods. But those cabinet mods generally involve modifying the trapdoor where you remove media. I don't want to put my siphon feed in the trapdoor. So I'm actually going to make it a part of the cabinet itself and leave the trapdoor as a trapdoor function so I can change media without having to worry about my tubes being in the way or needing to be moved or any of those sort of things. So what we're going to do is essentially make a two-part component. One part is going to be on the external of the cabinet, and it will contain a 3/8 inch hose connection point, an air bleeder screw, and then a reduced diameter to go in through a hole in the cabinet and internally threaded to accept what will be essentially a hollow bolt with cross-drilled holes that will bolt across the external rectangular portion of the cabinet. So it'll make a little more sense maybe if I draw this out. Let me move a few pieces here. So the bottom of my cabinet has this 5.5 inch rectangular, this is the front view, and then there's the small door here that is hinged and, you know, spring inside to pull it up closed and the whole deal. And you just push this door down and you can do very fast media changes. So what I'm going to do is create an adapter that is going to go here, okay, with a hose connection at 3/8 of an inch, and of course hollow all the way through. This adapter is going to pass through the wall at a smaller diameter, okay, and internally we're going to have this threaded to accept a bolt from the other side. So we'll have a hole here as well with this, I keep using the term bolt, but you'll see what I mean when we get there. So there'll be a bolt and then a long tube that goes all the way through here, okay? And there'll be holes drilled periodically throughout this tube for media pickup, and that tube is hollow and will thread into this end. And then the compression of threading the two together is what's going to hold that in the cabinet. So then I'll be able to siphon feed. We're going to have a media adjustment screw going in through here so I can bleed air in to slow down the media if I'd like. So we'll have that, and then we'll still be able to access this trapdoor. So we're going to start out on the 3-jaw, on the smaller lathe, because the large lathe has the collet chuck in it, and I don't want to put the big 6-jaw in because it's heavy and I don't feel like doing it. So we're going to turn this down, and what we'll do is we're going to turn down this 3/8 diameter and punch a quarter inch center hole through here, and that's going to then allow me to bring this over to the collet chuck and leverage the 3/8 here. So we'll do that one on the 3-jaw on the small lathe. We'll turn this whole thing on the large one since we have the collet chuck over there and we're using 1-inch stock, so I can get that in the collet chuck. This 1.25 inch, of course, I can't get into my collet chuck because it is larger than the collets. So I'm going to go set this up in the small lathe and move the camera, and we'll just start with this turning operation. And what we're going to do is just grip it on the end, and I want to turn down just a uniform finish, and then we're going to come in a distance, maybe 3/4 of an inch or so. It's not really critical, it's just enough to get a hose connection on there, and we'll turn that down to 3/8. Then what that will let us do is come back over onto the collet chuck and you know, grip this on the 3/8 portion because it's too big to grip anywhere else. So we'll grip it on the 3/8, and then we'll put our quarter center hole, work on the end features over here, but we're going to create these end features on the 3-jaw. So let me get set up over there, and we'll come right back. All right, we're at 122 on our diameter. We want to go down to 1 even, so we're going to dial this in a little bit. All right, we are 122. Let me zero my hand wheel, just going to use that. 20. All right, and we're going to go in a 1/2 inch. This is just for what's going to stick through the hole that we're going to cut in the side of the cabinet. Okay, so we're working on turning this down to 1 inch, and all this is really for is just to help align it in the cabinet. This is not really a critical dimension. We just need it to match the hole that we're going to drill in the side of the cabinet. All right, and we are at 110, so we're going to take 10 thou more off here. I'm sorry, 1.1, we're take 100 thou off. And again, it's just a little lip so it centers itself in the hole in the cabinet. We'll go halfway and check again, because we don't want to be too far off. Should be right near 105. Yep, 105. Let's dial her in. Here we go. And we're going to go a little bit under. You know, hole saws and drill bits aren't always accurate, and I'd rather have my hole just a teeny tiny bit big. Let's try that. Yeah, we're probably going to go just, I don't know, maybe 10 thou further in. And all I really want to do here is get this maybe, I don't know, maybe 10 thou under 1 inch. Just so it's an easier fit in the hole when we drill it later, without having to fight it. There we go. We are 10 thou under, 990. Perfect. So we're just going to clean up that back corner and then clean up the edges. Okay, so now what we're going to do is we're going to punch our 1/4 inch through hole all the way through the part, and that will basically give us, well, let me back this up. We're going to put a 1/4 inch through hole all the way through the part, but we're not going to do it right away. What we're going to do is we're going to drill our 1/4 inch hole through into about here, because that's still solid material that's in there. But we're also going to have to drill the larger hole for the tap. So that's going to be a 3/4 inch hole in here. So when we start tapping that, I don't want this internal piece to be so thin that it shears off. So we're going to go through and drill our hole out for our tap, and then we'll punch the last little bit with the 1/4 after we've gotten this tapped. Okay, so we've got our 1/4 inch drill bit in here, and we're just going to tighten this down. And like I said, we're going to put this pilot hole for the 11/16 that we need for the 3/4 inch tap. 3/4 16, we're going to tap this too. And I've got my tailstock lined up on 0. And I'm just going to tap it in with my hand until I start to feel drag on the tip of the bit. There we go. So now I know that I'm pretty close to my surface here. So then we're going to take our scale here, and we're going to say we want to go, boy, this one's hard to use here. I'm just going to use this. This will be a little easier. The only thing we want to do here is make sure that we don't go all the way through, that we leave some meat in here. So we're going to go ahead and bring that in precisely that far. You can see my awesome non-accurate measuring in any way, shape, or form, but all that really is it's roughly 1.5 inches. Let's look here. Yeah, 1.5 inches. That's all we're going to do. It's not critical. This is just the pilot hole for the tap. So, you know, the depth is fine. We're going to punch the rest through after this piece is done. So all good. But we're going to go 1.5 inches here. All right, we're running about 800 RPMs. We'll back this up, throw our 11/16 in here. I'm going to do that same thing, line up on 0, and use that same paper method. And again, none of these are critical dimensions, so I mean, that is, you know, close enough, right? Okay, I'm going to drop this down to 200 RPM. 235 if you want to get real technical here. All right, since we're in aluminum, we're just going to power tap this thing. Get some distance here. Pushing my tailstock back is all I'm doing, just to have it, give it room to slide. So when we do this, we leave the tailstock loose, we leave the quill lock loose, we leave everything loose, and we let the tailstock be pulled in by the momentum of the machine. But I like to do this in very low speeds. So we're going to go at 75 RPMs. Here we go, we got that started. We're going to back this off, and then we'll just finish it up with the actual tapping wrench. But boy, we might have to go and take that out. Woo. Whoops. Oh, now I got to find my tap. Ouch. There we go, we got our tapped hole done. I'm going to swap this out for our 1/4 inch drill bit and pop that through hole, and that'll be the end of the lathe work for this part. And this is still nice and slow from our tapping speed. We're just going to keep it there and peck away at it, since we're going to have a pretty thin wall in the end of this. All right, and there we are. See, we got a through hole all the way through our outside bore. This recess is going to set in a hole in the side of the cabinet. We're going to add our vent holes. We got our threading on the inside. So the rest of this piece will just be done on the mill, and all that's really going to be is popping in a vent hole and then a screw to adjust how much vent we want to add. And for anybody wondering, yes, this is for a hose connection. It's a 3/8 inch hose, but you gotta remember this is a suction line, not a pressure line. So I didn't put barbs in here because it's, you know, it's suction. It's gonna be fine with a little hose clamp on here, and I wanted it to be easier when I take the hose off. Taking them off hose barbs is always a pain in the butt if you need to change things. And again, because it's not a pressure line, I can get away with that. All right, so we're gonna go back over to the bench, set this piece down, and set up for the next part. Okay, here we are with the part that's going to become our bolt/siphon pickup. So we need to drill a hole 6 inches long through this. So we're of course going to start by facing center drilling and then get chucked up with the drill bit. So here we go. And we move the camera a little bit for you so you can see the drilling operation. There we go. Bring in our center drill. And using that same technique because we want to go 6 inches deep. And again, this isn't a critical measurement. It's, you know, just for a pickup tube on a I can't even say the word, sandblaster. There we go. So we got our tailstock quill on 0. We're lined up. Get some oil, and we'll go ahead and put a 6 inch long hole through this guy. So now if we didn't totally screw up, we should have basically a 6-inch hole. 6-inch deep. Let's take a look, see how close we got. Looks like we're at 5 3/4. Let's see here. What's that? Whoops. Yep, 5 3/4. We got another 1/4 inch to go. And again, these aren't critical dimensions, but I want to hit 6 inches. I want to hit 6 inches. And there we go. Just a hair under 6 inches, but accounting for the taper, the drill bit, etc., we're in a good spot. That's probably hot as heck. Yep. So we're just going to clean up the edge a little bit. Okay, now what we're going to end up having to do is pull this whole thing out, put it, you know, basically in the chuck and in the tailstock, and turn it down to 3/4 of an inch, nearly probably 70% of its length, 6 inches or so. So I'm going to get that pulled out, marked, and come back for measurement. Okay, here we go. So we've got our hole 6 inches through that we just cut. We've extended our stock and have our tail support in. And what we're going to do is we're going to turn this outer down to 3/4 of an inch for 6 inches. So I've lined up right here on the edge, and we're going to set our DRO to 0. So we've got that set to 0. And let's come on out and touch off the outside. And I'm going to dial in 0 over here on the DRO. This is 1 inch nominal, right? So we're going to dial in 0, then we're going to go into like 85. And then we'll figure out where we are from there. You know what? That's being lazy. I'm not actually going to do that. I'm going to cut this, measure it, punch it in the DRO, do it the right way. All right, let's see where we are. Come on. That's hilarious. That's 1 inch on the dot. All right, so we're going to go into 0.80. We're just going to take this in one shot here. We'll do a little bit and see where we are, and then take the full cut. You know what? I'm going to go into 0.90. I don't want to do a 100 thou depth of cut on this. It's just going to be too thin. All right, that should put us at 90 and change. All right, here we go. Let's go take a measurement. I'll let this cool off for a minute too, because it's probably pretty darn hot, which means our measurements aren't going to be totally accurate. Well, let's see what we got. Got 90 on the DRO. Let's see where we are here. And we are 90. All right, so we're going to go into 75 and just make that cut. DRO saying 79.90. That's hot. Woo boy. I'm getting about 81 here. Boy, we are right on 75 there. We're going to take that. Oh, that's pretty finished. Got some oil marks on it, a little warm. Probably going to come in a few thou under, which is perfectly fine. That's exactly what I actually wanted. So let's see where we are. When that cools off, it'll probably come in a couple under. Let's see here. Yeah, we're at 75 on the dot, so I wouldn't doubt if we come in a little bit. And that's using these cheapos, right? So this isn't really accurate, but it's good enough. So now what we're going to need to do is we're going to need to taper this end for tapping, okay? And then we're going to want to just clean this end up. So what I'm going to do is take this all out and put in a 3/4 inch collet. That way we can get closer to the end for tapering, flip it over to clean up the other end, and do those little, nice pretty bits. All right, here we go. I'm just going to use the file to bevel that instead of just changing tools. There we go. And let me go get our die all set up, and we'll come back and we'll thread the outside of this. All right, here we go. We're going to get ready to thread the end of this. And if you've been watching me long enough, you'll recognize what I'm doing here. A lot of people do this; it's pretty common. But we're going to take the face of our tailstock, and we're going to just put that up against the back of our die holder. Okay. And what that's going to do is help keep me square to the part as I start this thread. And it's fully my intent to do this by hand. So I've got my tailstock locked in place. We're going to put just light pressure on it with our hand while we turn it over here. Now what I'll end up needing to do is put my lathe in neutral. And now because we're here and this is jammed against the block, well, let me move this a little bit. I'm not sure if that's getting in your way or not. I also don't want it to get in the way of tapping straight. There we go. So I'm going to hold pressure with my other hand on the wheel as I turn using the key for our head here. There we go. And that gets me a nice square start to a thread. I do have some die holders for here, but not this size. I didn't make one for these larger dies yet, but it would be nice to have on something like this. Whoops, hit the camera, sorry. There we go. And now once we're started, I'm going to back all of this out of the way, now that I'm started square, including the camera, because the apron is in my way right now. There we go. Get this over here, and then I'll turn this so you guys can see. There we go. And we'll just tap this by hand. There we go. Bring it back over so you can see a better look here. Not sure if you can see that or not, but that tapped nicely. Feels good. We're just going to take a little bit of emery cloth and very lightly clean this up. We'll get out of the part and do a test fit. Perfect. Okay, so here we are off the lathe. We've got both of our parts. And you can see this is what I referred to as the bolt previously. Threaded on each end, hollow all the way through to here. Not hollow through, obviously, because we want this to be the pickup tube that picks up our media from the blast cabinet. So we're going to move over to the mill, and we've got a few operations to do. So on this one, we're going to drill a series of holes at 90 degrees along here for the media to be picked up, and it'll be drawn, from the vacuum of the Sandblast nozzle. And then on this end, we're going to put some flats on here so we can get a wrench on here just to make it a little easier to tighten. You can do it by hand. It doesn't need a lot of force since it's just a very slight vacuum from the Sandblast gun, but we'll go ahead and put some on there anyway. So the other end, this will be on the other side of the blast cabinet, and when we get over for assembly, you'll see what we mean. We've got it threaded inside. We've got our shoulder, so it sits in a small hole in the blast cabinet, registering firmly against the face, just as this registers firmly against the other side. These would then thread together, going through the door of the blast cabinet, as shown here. Here's our pickup tube that we're going to hook our media suction tube to. And then we have to put in our nozzle here, which will allow us to adjust the media flow rate by letting air leak in. So the more air we let leak in, the less air being pulled through where the media is, so you can slow down the media volume that's coming through your nozzle. So not only can you adjust pressure with the air pressure, but now we'll be able to adjust volume. Okay, here we are set up on the mill, and as you see, we've got a square collet block, and we have our 1-inch portion of the tube in the collet block extended outward, and then we have over here a V block and an adjustable block underneath it to just hold that stable, because we're just going to be doing some drilling in here, so we don't have a lot of side load, but vertical only, so we need to support that because of the stick out, obviously. So what we're going to do is we're going to find center like you always do, and then go through and just drill some holes in here, rotate it 90 degrees, which will still keep our center in the correct location, and then drill alternate holes on the other side. So we're going to stagger these. They're not going to be even, so it'll be a hole here, and then a hole here, and a hole here, and a hole here. And honestly, I'm just going to eyeball this, since all it's for is a pickup inside the sandblasting cabinet. The distance isn't really critical, so we'll just go ahead and pop those in. So we'll start out by, finding center here. Okay, put our 0 on the DRO. And I went a little too aggressively there. And I gotta come down a little more. There we go. All right. 94.38, so we're just going to cut that in two. All right, so 47.19 is going to be our center. Let's go ahead and dial in 47.19. There we go, and we should be right on center here. We'll go ahead and drop this down and chuck up our drill bit. And quite honestly, I'm cheating a little bit here, and I'll tell you why in just a second. There we go. We're going to be putting 1/4-inch holes in this, which are rather large for the internal diameter. But the reason that we're doing that is we want to be sure that media isn't going to pile up when we start vacuuming through here, because that media is sharp and angular, and as the pieces come together, if the hole is too small, they can actually build up and effectively lock themselves tight and plug a hole. So a large enough hole really helps to prevent that. Okay, so let's just come down and take a quick peek. Okay, yeah, we're center there. This is a split point drill bit, so it does a good job of drilling, and we're using a 1/4-inch bit. So yeah, on a round surface, in all correctness, I should be spot drilling or putting a flat in there, but we're just going to kind of go with it. So let's come down, and we're going to set. Okay, we got some distance for the wall that needs to exist inside. So we're going to go. Hold on, let me see. Let's 0 that first. We'll give us a 0 here just to give us something. Okay, and we're going to go in 3/4 of an inch. One, 2, 3, 4, and 5. Here we go. Get a little oil. We're going to run this at 800 RPM here. Okay, and there we go for our first set of holes. Now we're going to take and loosen our clamps, remove our piece from the fixture, and just turn it 90 degrees to drill the other set. Okay, I'm nice and snug there. So now we're going to do the exact same thing. Basically come down here and go an inch over and continue drilling holes in the opposite direction. There we go. We're going to take this out, clean it all up, deburr all the edges, and then we're going to set up to do the piece here where we have to drill the vent hole and then tap through it. Okay, so I'm going to go over my setup here and how I have this clamped in and what we're going to do. So here you can see I've got the same collet block we had previously. I have another collet block on this side, and this is just to balance the forces on the vise. These collet blocks have the same exterior dimension. So we've got that in there just so it clamps squarely and tightly. I've got this 1, 2, 3 block that was just sitting here, and this is what I use to square up this collet block. So I just gave it a nice tight squeeze, held to the bottom while I tightened the vise, and checked it with a flashlight behind. I had no light passing through. I know that I'm very perpendicular here. And what we're going to be doing is drilling a hole down here that we're then going to intersect from the side. And because we already dialed everything in when we had this collet block on its side, simply tipping it up has kept our center point in line. We haven't changed anything there. So I'm still going to be able to go center here, and then when I tip it down to drill the intersecting hole, we're still going to be centered. So a really nice aspect of using these blocks like that is that you can keep things coaxially located so they stay in the same relative location. So here we've got a 3/16 drill bit, which should be far more than enough air ever needed when we come through. And I honestly haven't decided what size set screw I'm going to use for the bleeder valve. That really is actually going to come down to honestly what screws I have available. I'm going to use some cap head screws and just something knurled that I can tighten in there nice and easily. So we're going to come in and we're going to come to a decent location. What we want to have is our hole all the way through here, roughly centered. And that doesn't really matter because this only intersects the hole we're going to cross. When we drill in from this side, this one will have to be a specific depth so we don't pass through our opening area here. But this is just an air hole, that's all that is. So let's see here, I'm going to come in just a little bit more. There we go, snug my table up. And we're at the same 800 RPM we were for the previous drilling operation. So we're just going to peck this thing through. Let me set my DRO just so I keep reference here. What I want to do is drive this past a little bit, and we're going to set our stop. There we go. Okay, and there's our depth stop. We'll come back to our 0. Again, not critical, just gives us a nice way to come back to home. There we go. We're going to take this slow because there's very little material holding this in here. I hope this doesn't turn into a catastrophe. If it does, you guys get to be the first to watch it. There's our nice little air bleeder hole. And we'll just go and, let me see, I think I might even do that while we're here. Yeah, I'm going to put a small countersink on there just to chamfer that edge a little bit. Yeah, that'll work. There we go. That's a nice smooth edge. Okay, so now we have to flip this part, but that means it's going to be sticking out with almost nothing holding, so we have to do some other reinforcement to hold this in location here. So we're going to flip it because we already have our centers located, and all I have to do is put this side up in order to make sure I intersect correctly. So I'm going to go ahead and reset that, and then we'll come back with how I set this up. Okay, here we are with a very similar setup to when we had the full length sticking out with our adjustable block under here for some support. There is maybe, I don't know, maybe less than a 1/4 inch probably in this block holding this. If this were anything but aluminum, there's probably no way you'd be able to get away with this. This is just a sketchy setup all across the board, but this should work if we go nice and easy. This is a number 7 bit for an M6x1 cap screw that we're going to put in. So I got the tap sitting here. So when we go ahead and do this, we're going to drill this. There's no way we'll be able to tap this in this setup. The torque will just pull it right out. But we can get the tap lined up and started by hand, and then we can just finish it as needed. So we're going to go ahead and cross our fingers and hope that this does not rip out of this collet block for us. So let's see what happens. So I'm going to come over here and we're going to set our depth. That all we really need to do is get past the hole and break into the center. So let's come here. There we go. So there is past our hole, broken into the center. We'll set our stop. Okay. And we're going to drill right over the support screw underneath so all of our forces are centered. There we go. Snug our table up. Start the drill. Yeah, I think that'll be good. We'll go ahead and use that. Just to give our tap something nicer to start with. There we go. Get all that junk out of the way just so there's nothing that's going to mess with our tap. Now I'm just using this to guide the tap. I'm not going to actually tap under power here. Machine in neutral. You see I can spin the chuck by hand now. There we go, a little oil. And slight downward pressure on the handle up above. There we go. And that's all we wanted, was enough room to get this in. There we go. Actually, we're going to change this. That's too much torque. I'm going to pull this out and probably deform that edge. So I'm going to put it in the V-block just to clamp it in here, just so we can tap it with a little more rigidity to it. Okay, we just took it out of that collet, and you can see that's all that was there. That much material, maybe a 1/4 inch. I didn't even measure it when I made it. It's just a lip that I put on there. That's all that was holding it for that drilling operation at the start of this tapping. So we're just going to put it over here, tighten it in, and finish tapping it by hand right here. Okay, we'll try out our screw, see how we did. Perfect. Okay, and here we're set up to put some wrench flats in the outer surface. You saw me cut the 6-sided exterior, the hexagonal 6, 8, 6. Okay, I forgot which one I had over there. But all we're really going to do here is drive in until we skate this side, and then go say 100 thou, and then do the same thing on the opposite. This is just to put some flats on. The dimensions don't matter at all. It's just so I can get some sort of spanner, crescent wrench, whatever on there to help tighten it down. Okay, here we go with our finished parts. You can see the pickup tube that goes inside for the media pickup inside the sandblasting cabinet. Put that nice 6-sided nut on the end. It wasn't any particular size, it's just something I can put a crescent wrench on. And the same thing for the flats on here, no particular size, just something that we can put a wrench on to hold this in place. There is our metering valve with the hole that goes through and meets to the inside. So we're going to go over to the cabinet and install these pieces on the cabinet, and we'll show you how this all works. Okay, here we are at the sandblasting cabinet. You can see we drilled a hole in this side and a hole in this side for our tube to pass through. Get this position here. And all we did was, like everything else, a center punch. Then we drilled a starter hole and used one of these step bits to drill the appropriate size hole. All right, so now we're going to go and put our components together. So all we really do is take our pickup tube and we slide it through this side. 2 different size holes because, they're 2 different size components. Okay. And then we take our valve, and you notice it recesses. That was the point of this seat. Let me move this a little bit, maybe you can't see that. There we go. So this recesses in here, and that metering valve, I can move that to any position I want. We're just going to keep it up and out of the way for right now. And then we just tighten this down. There we go, and our pickup tube connects right to here. So I'm going to go ahead and get some media in here. As you can see, the door is open, so there's no media in there. We'll have to reconnect the spring, put some media in, and put our tube on, and then we'll come back and see how well this thing does. Okay, so here we are at the sandblasting cabinet, and I placed a bucket underneath because I was making a mess. I've got stuff all over the floor. That has nothing to do with what we built here, but you can see I've got the component installed as we did in the end of the previous segment, and we've got our bleeder screw sticking out, and then our hose going up to our blast cabinet. So what I'm going to do is go ahead and mount this where the camera can see through the window of the blast cabinet. hopefully you'll be able to see this. We've got a piece of material in here, and that is nothing more than a piece of hot rolled steel with mill scale. And mill scale is one of the tougher things to remove. So we're going to go ahead and blast this with the limiter screw all the way down, in other words, full media, and then we'll back it all the way out and just see the difference in the blasting. So let me go ahead and get the camera positioned, get all set up for that, and we'll go into that segment in just a second here. Okay, here we go, and we've got the mixture screw screwed all the way in other words, full media. We're not bleeding off anything here. This is going to be kind of hard to do a really good test because this is going to be based upon the rate I move at, how far I hold. I'm going to try and be consistent here, but we'll see. So this is full media. I'm going to let the gun clear and purge itself first, and then go ahead and just blasting across the surface. Okay, and there we have it at full media. All right, so let's go ahead and turn the mixture screw down quite a bit. Okay, I have the mixture screw almost all of the way out, so it should be as lean as it can get. We'll purge the gun again. Okay, now let's see if we can see the difference here. So you can see the same 3 passes. We have significantly more scale removal here and significantly less here. I tried to maintain the same distance, but what that really allows us to do, as you can see, is get very deep cleaning or very, very light on the surface here. It would take many more passes. Let me see if I can catch an angle that shows it. That shows it a little bit more, where you can see this section has been blasted much deeper than this section here, using the same amount of time, far less media. So you can adjust how much is coming out to adjust how sensitive you want to be. And of course, distance and speed comes into play there as well. But so far, this project has been a success. I hope you enjoyed the build. I hope you enjoyed the video. And if you have any questions, comment below. Thank you very much.